All right. Good morning, everyone. How are you?
We're fine.
Okay. I think we have 6 people online, and if you look at our WhatsApp group, we have up to like that. I think 35 or 34 people. But we are not going to waste time. These are online lectures. We don't have much time, so we just wait for another minute, then we can start with the course. Of course, this is mathematics for business and social sciences. I have just shared the course outline with you on WhatsApp group. As we go on, some of the materials also will be shared based on the lectures that I will do or did. So those are some of the things I want to put across. Today, if you look at the course outline that I share with you, we will be looking at a linear equation. Some of these you have seen it, but it's important we do a refresher. Are you guys hearing me very well?
Yes.
Okay. So we will look at linear equations. So we'll spend some time with that. But the goal of this class is more about application. How do we apply mathematics in economics, in business, in other social sciences, HR as well. So this is what we will be looking at. The assumption is you have some maths background, but experience has told me that that's not the case for many people. So we will be looking at the maths component as well as the application as well. So today we will start with the first chapter or part, which is linear equation. And that's what we are going to look. Or then over time, we will go to non-linear equation. Then from there, we will look at differentiation, which has to do with calculus, which so most of you haven't seen in high school. So linear and non-linear equation, we looked at them, but the goal there is to look at their application in the business world, in economics and other social sciences as well. So without much wasting much time, we can start the class. We have waited for 3 minutes already. So today, what I want to cover with you will be this. Let's take this as a physical class. Let's take notes. The videos, we know sometimes the quality of the recording can be poor. Sometimes light goes off and recording can be so difficult. So as I am explaining, see this as a real classroom and you take note as well. So that if the recordings are not available, then you can stick with the notes that you took during the class. So today we will look at chapter 1. I hope everyone is seeing the whiteboard. So linear equation is something you have seen. Most probably is the application you haven't seen in the business world or in the economics. So we looked at linear equation in chapter 1. And on the linear equation, some of the things that I want to cover will be this. First, it is important we know what are we talking about. So what is linear equation? This is not a definition. It is a mathematics. We have to do some, try to see the format, how linear equation look like. So what is linear equation? So it is important to be able to identify what kind of equation we are dealing with. Is it a linear? Is it non-linear? We have linear equation. So we will also look at, on the linear equation, we will also look at forms of linear equation. What kind of forms of linear equation? We will look at this. So I don't know whether time will permit us to be able to do all this. Then the third one, we will look at the solution. How do we find solution to linear equation? From there also we looked at graph. How do we graph linear equation? So all these 1 up to 4, they will come handy once we start to do application of linear equation in business and other sciences as well as in economics. Then graph of linear equation. Then we'll also look at where we have two or more linear equations that we bring them together. So in your high school, some of them must have had it simultaneous. Linear equation. So some people call it a system of equation or system of linear equation. So the word system is trying to justify that we have more than one linear equations. So once we do this, remember this course is more about what? Application. So we will, after we equipped ourselves with these mathematical tools, these are mathematical tools, and we want to apply them in real world. So one of the application will be what? We will use it to analyze what? Demand and supply. Some of you, I'm sure you have taken economics courses already. So how can we use maths and analyze demand and supply analysis? So we will be equipped with these mathematical tools to do analysis of demand and supply. And then the other application is national income. So we will use it to analyze to determine what? National income. And when you talk about, obviously, I'm sure all of you have taken economic courses whereby you look at the aggregate GDP and others. So national income is the same as GDP, gross domestic product. So how can we use mathematics to analyze that? Or to be more specific, how can we use linear equation that comes from mathematics to analyze national income or national income determination? So this is our roadmap for chapter 1. This is what we want to achieve over time. So these 6 and 7, they are what? Application of linear equation in business, in economics, and other worlds. So this is our roadmap that we want to take for the chapter 1. So we start from what is linear equation, then we keep going until maybe this lecture we might not finish it, even next lecture. This is what we want to achieve in this chapter. So let's get to it. Let's get into it and start it with 1. So what do we understand by linear equation? So we have 16 participants or 15. The 16th one is myself. So we have what is a linear equation? There is no need to memorize this. We just looked at the form of the, how it's more about how to identify a linear equation from non-linear equation. That's the goal here. So when we talked about linear equation, normally it comes in this form. We have A. I will explain all these parameters to you. So A is being multiplied by X. Then we have them that term of the equation is added to, let's say B, but B is being multiplied by by y. B is being multiplied by y. Then we have, which is equals to what? C. So linear equation is always in this form. I will explain each of the letters in this equation if you give me time. First, one thing we need to know about linear equation, especially in form of two variables. First, you know, it has two variables. It could be one, it could be two, but in this case, what we are seeing here, it has two variables. This is what we need to know about that. It has two variables. It could be one variable, but what we are seeing here for this case, we are focusing on this equation. So it has two variables, and these variables are what? Are the ones is what? X and Y. So if you look at these variables, X and Y, so we can even do it like this to be more specific. These are the variables. X and Y are the variables. So variable in mathematics means they can take any number. So the A and B, A is what? A is a coefficient. A is a coefficient that is attached, because obviously we have seen equation in high school. So this AX is a term within this equation. BY is a term and C is a term. So the first term, which is this one, a coefficient is being multiplied by a variable. We have a coefficient. A is the coefficient of X. So the second term here within this equation is by. The y there is the variable, and the b there is the coefficient. So the c term of the equation, we call it constant. But the name linear itself comes as a result of the name linear equation comes because the variables, which is x and y, the highest power they have, it's what? It's 1. If you see any variable that is written and there is no power to it, you can assume that it has 1. So if the power instead of 1 here, it's 2, we cannot call it a linear equation. So if you see an equation like this, and when you talk about equation, it's just a mathematical expression separated by what? An equals to sign. So if you have a term on the left-hand side of the equation and on the right-hand side of the equation separated by equals to sign, we can call it an equation. So if we have an equation and the variable, the highest power there within a variable is 1, then we can call it a linear equation. If at all this is not 1 but is 2, then we have 1 here, then we cannot call this equation a linear equation. It will be quadratic. So as long as all the variable, the highest power within that equation is 1, then we can call that equation a linear equation, irrespective of how it is stated. So for example, how do we identify a linear equation? You look at first, you have to identify the variables. And in this equation, the variables there are what? X and Y. And if you look at their power, is 1. And the power here also is 1, even though it was not written initially. If you see a variable that is not having a power, know that it's raised to the power of 1. Because x raised to the power of 1 is still x. So for a linear equation, for us to have a linear equation, we must have what? Equation first. Second, we must have variables within that equation. It can be 1 variable, it can be 2 variables, it can be 3 variables, and it goes on. We must have variables. And the third part is that the highest power within the equation should be 1. So these are some of the conditions that must be met for us to have a linear equation. the highest power there must be 1. So we see that x and y are the variables within this equation here we have. And their power, the highest power there is 1. X is the highest power is 1. Here is 1. So we can conclude that we have a linear equation. First, we must have an equation. Second, there must be variable within that equation. And third, the highest power within that equation must be 1. So if it's 1, then we can conclude that we have a linear equation. So this is what we mean by linear equation. It's not a English definition. It's for you to identify what kind of equation we have. For example, this is a general form, what we have here. But to be more specific, we can have something like 4x plus 2y equals to 6. So obviously the 4 here is the A, and the 2 here is the B. And of course, x here is here, and y here is here, and 6 is the C here. So this is a general, we call this a general form. We call this the general form. So some people might even call it the standard form. But we will see forms of linear equation. But what we mean by general or standard form is that, we don't have numbers here. For A and B and C, there is no numbers. But for this one, it's a specific case. When you have numbers that are slotted in, we call it a specific case. So obviously, 4x plus 2y equals to 6. If you looked at this, this is an equation. Because of this, we have equals to sign. And we have variables there. And the variables are what? X and y. And the highest power here is 1. Because the highest power there is 1, then we can classify this equation as a linear equation. So this is how we identify linear equation. For example, if we have something like this, 4 times x raised to the power of 2, this is 2. Then plus 2, then we have 2y. This y, even you don't write anything there, the power is 1, then equals to 6. We cannot call this a linear, this one, a linear equation.
No.
Because of this. So this is how we identify linear equation. So if we don't have any question, we have completed the first part of this, the identification of what is linear equation. If you have a question, you can raise it, or any comment or anything you want to add to the lectures. Let's make this class interactive,
Okay.
So if you don't have any comment, or if you want to add something, the floor is open for everyone.
It's clear. Let's move on.
That's clear. So this is how we identify linear equations. So let's look at some forms of linear equations. Sometimes experience have taught me, like some student, when linear equation is twisted, it confuses some students. So it can come in many forms. You understand? So let's look at some of the forms where these linear equations can come in. So we looked at two forms of linear equations. So when we said forms of linear equation, if your memory can serve you well, we have looked at even one of them. This equation is one form of linear equation. So first one that we will look at is the general form that we just even talked about. We can have a linear equation as as this. That's where we just talked about. So we have standard form, we have general form. So the general forms looks like this, but however you state it, still the concept, the idea can be applicable to any form. So we have bx, so minus c equals to 0. So this is the general form. So if we want to turn the general form to standard form, which we have just looked at, now this is a standard form, but here the word general I use means that, okay, we are not making it to be more specific, like using 4 and 2. But when we talked about the forms of linear equation, this is the general form whereby the constant is moved to the left part of the equation. So the standard form that you normally see in textbooks, or the one I used in previous slide, standard form. So to have standard form, you just move this to the other side of the equation. So we will have what? Ax plus b y equals to c. So still x and y's are our variables. Let's not forget that x and y's are our variable. The a and b are the coefficients of the variable within the linear equation, and the y is what? The constant. But together, a, b, and c, sometimes you will hear things like parameters, you understand, which we will see them later in this course at due time. So the a, b, and c, one can call them in parameters in mathematics. So we have general form, we have standard form, and then we have what? Slope intercept form as well. So we can also have linear equation expressed as what? Slope intercept form. So slope intercept form, this is how demand and supply and other applications, the models in economic, most times they use slope intercept form, but we will talk about this later as times goes on. So when they talked about slope intercept form, normally it's written, that is y is made as a subject of the formula. We have y mx plus b. So y here, it's made as a subject of the formula. So for general form and standard form, you cannot say that, okay, y equals to this or x equals to this. But for slope intercept form, we have y, we express y in terms of x and other parameters. So normally in most applications, especially demand and supply, we use this. This is a pop-up menu. It is telling us that after 10 minutes, the system will shut down by itself. But as usual, you know, I will log back, and you can log back as well. Then we continue with the lectures. So let's continue. So we have more than 3 forms, but for this course, these are the standard that we will focus on: the general form, the standard form, and slope intercept form. We will spend more time to look at this, but for now, let's know that, you know, there's a slope intercept form, and the m there, it's nothing. The m there, it's nothing but the slope. This is the slope. We will talk more about the slope as time goes on. Slope. So, but b here is the y-intercept. So we will hear more about this. But for now, let's know that we can express, for example, a good example is this. Like we can set 4x in specific form minus 2y plus 6 equals to 0. So if you see a linear equation like this, it's in general form. Or we can express it in standard form as what? 4x minus 2y equals to minus 6. So, but we can also have it in this way. We can also have it in this way, like here, y equals to, let's say 2x minus 4. So this is slope-intercept form. So you can have linear equation expressed in many ways. It can be expressed in this way, which is general form. It can be expressed in this way, which is standard form, and it can be expressed in this way, which is slope-intercept form. So which one you come across should not make you confused. You should be able to deal with them. You can use the same method to solve all of them. So once we know, and if you looked at our definition of what is a linear equation, it's the same. The consistency is still there because we have two variables here. We have a variable here, and the highest power still is 1, 1. The power here is 1, it's 1. So the power here also is 1 and also is here. Still, they are linear equation. It's just they keep twisting them, moving one variable to the other side. That's what is happening, or moving a constant to the other side. We have other forms as well, but these are the forms that we will focus on. If you look at some textbook, you will see point slope form, something like that. But for now, A, B, C, this is what we will focus on in this course. If you have a comment or you want to ask any question, you can go ahead before we move to solution to linear equations. How do we solve linear equations? That's what we will be looking at in our next slide. Okay, I guess everything is clear. So we move to the third part of today's lectures. We have covered this. So we are here now. So solution to linear equation. How do we find solution to a linear equation? So the linear equation could be expressed. Remember, we said ax plus by equals to c. This is a linear equation. So we also have another form whereby we can have ax plus by minus c equals to 0, or it could be expressed as y equals to mx plus b. So we even have given examples of this, like this, and a good example could be like, let's say 2x plus can we mute our mics if we are speaking to a third party, please? By equals to, let's say 2. So an example like this could be 2x plus 4y minus 2. An example could here be y equals to 3x plus 6. So if we have this kind of equations in any form, it could be this. Now, how do we solve this? How do we solve this? How do we solve this? So when we talk about solution to linear equation like this, solution of linear equations, what it is telling us, we have to find the value of x and y. When solution to an equation, if they said find solution to an equation, what it means, they want you to find the numerical value of the variables within that equation. So solution of linear equation, what they are asking us is to find the value of x and y. That if we multiply the value of x by a, and if we multiply the value of y by b, and we add them, should give us c. So we are trying to find the value of x and y that will make this equation true. For example, let's take this example. Let's say that we have a linear equation like this, 2x minus 3y. Most of these things, I think you have seen them in high school. That's my assumption. So, but we still go back to refresh our minds. So when you have this kind of equation, first, what you have to do is to identify what kind of equation you are dealing with. If, of course, we know it's an equation, we have this equals to sign here. If after you know that it's an equation, you ask yourself, what kind of equation am I dealing here? Is it linear or non-linear? So we know how to identify linear. We know that we have x and y as variable. And the power here is 1 and the power is here is 1. So obviously we know it's a linear equation. The next question is, how do you solve it? The solution to this linear equation is to find the value of this variable and the value of this variable. And that value, if the value of x, if you multiply it by 2, and the value of y, if you multiply it by 3, then the value here minus here should give us 7. So if you looked at it very well, these values, I will give it to you, but in due course, we will be able to find them. So the solution to this is x should be 5, and y should be 1. So if you look at this, 2 times 5 is what? Is 10. That then minus 3 times 1. We said that the value of y is 1.
It's 10.
So that will give us 3. So 10 minus 3, it will give us
7.
So the solution to this linear equation is what? We must have, remember, we have this coordinate system. If you have done geometry in high school, we have
Yes.
this, and we have y-axis, and we have x-axis. So normally x is here, and then y is here. So the solution to this linear equation, this one, is what? In x coordinates, we have 10. In y coordinate, we have 3. Because it's only when x equals to 10 and y equals to 3, these two combinations that we can have 7. So the solution is what? X must be 10 and y must be 3. So